Hello everyone. Now today we have to see what is meant by LC oscillation. LC, for LC oscillation we want LC circuit means circuit which consists of capacitor of capacitance C and inductor of inductance L. See, now what happens in this case? The electrostatic energy of a capacitor is converted into magnetic field energy of the inductance, and then magnetic field energy is converted into electrostatic energy, and this process of conversion of electrostatic energy into magnetic energy and magnetic field energy into electrostatic energy is repeated again and again, and this conversion produces the oscillations of desired frequency, electric oscillations of desired frequency, which are called as LC oscillation. The whole phenomenon we have to explain with the help of these 5 figures. See, in the figure 1, what happens? In the figure 1, let us consider the capacitor of capacitance C, and this capacitor is fully charged and its initial charge is Q0. So its initial or maximum electrostatic energy is UE is equal to 1 by 2 Q0 square upon C. This we have taken in the previous chapter. Now what happens? This capacitor is then connected to the inductance. Initially the current flowing through the circuit is equal to 0. So what happens? The magnetic field energy of the inductor is also 0. Now then see. Now what happens? When the capacitor begins to discharge, means it sends the current throughout the circuit. Then let I be the current flowing through this circuit, and this I current is then flowing through the inductance coil, and due to that the magnetic field is produced in the surrounding space or around the inductance coil L, and this magnetic field is shown by these magnetic lines of force C now, right? So what happens then? As the current produces the magnetic field, so magnetic field energy is stored in this inductance, and that magnetic field energy is given by UB is equal to 1 by 2 Li square, where L is the inductance of the coil and I is the current flowing to the coil. We know as the current increases, then magnetic field energy also increases. In the third figure, see, when the capacitor is fully discharged, then what happens? The potential across the plates of capacitor becomes 0, and that's why this produces the maximum current throughout the circuit, or it flows the maximum current throughout the circuit. So the maximum current is shown by I0, or that is also called as peak value of current, and this maximum current is then flowing to this inductance coil, so its magnetic field energy is also maximum, and that magnetic field energy is given by UB is equal to 1 by 2 L into I0 square. I0 is the maximum current, so magnetic field energy also maximum. Now what happens after the discharge of this capacitor? After the discharge of that capacitor, what happens? The magnetic flux linked with the coil goes on decreasing, and this decrease in magnetic field energy of the coil, magnetic field of the coil or magnetic flux of the coil, it induces the current throughout the circuit, and this current I is then flowing in the same direction. This current is then flowing through this capacitor, and capacitor again begins to charge. When the capacitor is fully charged, when the capacitor is fully charged in with a polarity which is opposite to the initial state. See, in the initial state, the upper plate is positive plate and lower plate is negative plate. So in this case, what happens? Lower plate is positive plate and upper plate is negative plate. So capacitor is fully charged. Then what happens? Then current flowing through the circuit becomes 0, and the magnetic field energy of the inductance coil also becomes 0, and this maximum potential energy, electrostatic potential energy of the capacitor is again UE is equal to 1 by 2 Q0 square upon C. So this energy is similar to the initial stage. UE is equal to 1 by 2 Q0 square upon C, and here also UE is equal to 1 by 2 Q0 square upon C, means the entire magnetic field energy of the inductance coil is converted into electrostatic energy of the capacitor, right? And this process of conversion of electrostatic energy of capacitor into the magnetic field energy of the inductor, or magnetic field energy of the inductor into the electrostatic energy of the capacitor goes on repeating, or this conversion is then produces the electrical oscillations of desired frequency, which are called as LC oscillations. And as there is no loss of energy throughout the circuit or throughout this phenomenon, so what you can say, the amplitude of all the oscillation remains constant, and that's why these oscillations are also called as undamped oscillation. Undamped oscillation means what? There is no decrease in amplitude of the oscillation, so they are undamped oscillation. So these are the LC oscillations. Thank you.